Hi, welcome back to Physics Teacher, the channel that prepares you for the high school math, chemistry, and physics contests from Waterloo University. This is a question from the Chem13 exam, which is the grade 12 chemistry contest. Give it a try, and I'll be right back with the solution. Alright, so this question seems like a typical grade 12 chemistry class question where you're trying to figure out how many molecules are ionized in acetic acid. But there is a trick to this question, and that is in the molarity of acetic acid. It's extremely small. So let's see where that's going to lead us. So we'll start with the equilibrium equation. We have CH3, COOH. Have our double harpoons there, CH3, COO, and this H is going to come off, and we're left with our ions. Next, we're going to make our ice chart to help us. So the initial amount of acetic acid is 1.8 times 10 to the minus 5. And these initially don't have anything at all. And then the change will be, well, this will lose a little bit, some amount x, and these two will gain that amount x. And so our equilibrium becomes 1.8 times 10 to the minus 5 minus x, and then these are both x. Now our association constant Ka, which is given, we can also write it as the products of our products, so x times x, divided by the reactants. So we have 1.8 times 10 to the minus 5 minus x. And this is where the trick comes in. In most questions in, say, a textbook, you might have, for example, 1 mole per liter of acetic acid. And therefore you say that x is incredibly small compared to 1, and so you cross it out. If you were to do that here, you would end up calculating your answers almost 100%, which is what a lot of students did. In this case, this number is so small, we can't ignore this minus x. So what I'm going to do is make this equation a little bit more simple. And they do throw this in, the fact that the amount, or the molarity of acetic acid, has the same value as your association constant. And I'm just going to call that A. So let's do let A equals 1.8 times 10 to the minus 5. So then this equation is just going to be A equals x squared all divided by A minus x. And that's the equation I'm going to solve. Alright, so if I cross multiply here, you'll get A times A minus x equals x squared. Now I'll distribute the A, and we get A squared minus AX equals x squared. So this is a quadratic, so if I rearrange it as such, we'll get x squared plus AX minus A squared equals 0. And now we can apply the quadratic formula to solve for x, where x is going to equal minus our b coefficient, which is negative A, plus or minus the square root of b squared, so we have a squared, minus 4a, which is not this a, but our a coefficient here in front of x squared, which is just 1, times by our c coefficient right here, which is negative a squared. And that is all divided by 2 times our a coefficient here, which is 1. Okay, so I can simplify this a little now. So x equals minus a plus or minus. Now in the square root, we have a squared. And then we have a double negative, so plus 4a squared. Well, that's 5a squared. Or I can pull out the square root of a squared as just a, and we're left with the square root of 5. And then that's all divided by 2 times 1, which is 2. And this leaves us with two possible solutions. Either x is minus a plus a root 5 all over 2, or x equals minus a root 5 all over 2. So in this case, I can pull out an a and simply have it as a over 2 times by minus 1 plus root 5, or x equals minus a over 2 times by 1 plus root 5. Now you can see in this case we are going to get a negative answer. We don't want a negative answer, so this one we are going to ignore. Whereas in this one, we won't get a negative answer because the square root of 5 is greater than 1. So now if we plug in back a, which is 1.8 times 10 to the minus 5, all divided by 2, times by negative 1 plus the square root of 5, we get 1.112 times 10 to the minus 5. Therefore, our percent ionization looks at how much hydrogen ions we are left with, which is 1.112 times 10 to the minus 5, divided by how much acetic acid we started with, which is 1.8 times 10 to the minus 5, and multiply that by 100%, and we get 62%. So our answer is D.